Okay, this is part 4 of our lesson on graphing rational functions. We're picking up here with number 5, and again, we're looking at rational functions with all the toppings: vertical asymptotes, horizontal asymptotes, slant asymptotes, holes. We will also talk about whether or not these functions are continuous or discontinuous. Okay, number 5. Probably best to start with the horizontal asymptote actually. We look at the degree, we see that the degrees are equal. That means the horizontal asymptote will come from the leading coefficients, 2 over 1. 2 over 1 is 2, so the horizontal asymptote will be y equals 2. Now the vertical asymptotes come from the denominator. So it's time to factor everything we can. So, well, first of all, real quick, since there's a horizontal asymptote, there will not be any slant asymptote. So I'm just going to put none. You'll have a slant asymptote only when the numerator degree is 1 more than the bottom. Now, factoring. Looking at this bottom part, grouping is about to jump off. Anytime you see 4 terms, think about grouping. If I look at the first 2 terms, GCF is x squared. So if I pull away the x squared, then that's going to leave behind x plus 1. And then on the other side, this pair, if I pull out a negative 9, then that's going to leave behind, again, x plus 1. Alright, if that's not obvious to you, imagine taking this negative 9 and doing the distributive property. Negative 9 times x is negative 9x. Negative 9 times 1 is negative 9. It gets you back to where you started from. Once you have that, then you see how we have these x plus 1s that are the same? You can pull that out front. Okay, pull that out as a GCF. And that's going to leave behind x squared minus 9. But we don't stop there. Oh no, because x squared minus 9 can factor further as x plus 3 times x minus 3. Okay, so this is the complete factorization of the denominator right here. Meanwhile, the numerator, let's factor that. Again, I see a common factor here. So if I bring out a GCF of 2x, all of these are divisible by 2 and they all have an x. So the GCF is 2x. Alright, that's going to leave behind, alright, dividing all of these by 2x, I'm going to have x squared plus 2x plus 1. Again, imagine doing the distributive property. 2x times x squared will be 2x to the third power. 2x times 2x would make 4x squared. And 2x times 1 would give me the 2x. Now, I'm betting that this will factor further. So x squared, of course, will be x times x. 1 can only be 1 times 1. Now, inner plus outer equals middle. Alright, if I make these both positive, inner I have 1x, outer I have 1x. That makes 2x. Alright, also positive times a positive is a positive. And don't forget about the 2x out here in the front. So this is a complete factorization of the numerator. Okay, let's put all that together right now. Okay, so f of x equals. So I have a denominator of x plus 1 times x plus 3 times x minus 3. And I have a numerator of 2x times x plus 1 times x plus 1. Whoops, too many parentheses. Okay, so if anything cancels out, that's going to give me a whole instead of a vertical asymptote. Otherwise, I'd have 3 vertical asymptotes. But something does cancel out. I have an x plus 1 in the top and the bottom. Alright, so this x plus 1 will not yield an asymptote. It will instead give me a whole. So if I take that x plus 1 and set it equal to 0, alright, subtracting 1, I get x equals negative 1. Okay, that tells me that I'm going to have a whole. Okay, I'm going to have a whole at, alright, this is trying to be an at symbol. I'm going to have a whole at negative 1, comma, something. Hi, sweetie.
Hi, this is my last. This is the second bag.
Alright, good job. So I'm going to have a whole at negative 1, comma, something. Now, if I want to figure out what the y value of the whole is, I need to put this function into my calculator, alright, without the crossed out part. So in my calculator, I'm going to put in 2x times x plus 1 over x plus 3 times x minus 3. Okay, let's do that now. So we'll table it up. Let's clear that out. Alright, what I say in the numerator, I'm going to have 2x times, what was it, x plus 1, I believe. Alright, and in the denominator, I believe we had x plus 3 times x minus 3. Okay, alright. Now, I want to know what's going on at negative 1. So when I go in there, I'm going to set it to, well, no. I'm going to set it to negative 1. Alright, so at negative 1, it's 0. Negative 1, comma 0. Okay, so that's the whole. When factors cancel out, that gives you a whole. Now, these other 2 factors in the denominator are going to give us some vertical asymptotes. Right? So, if I do x plus 3 equals 0, subtracting 3 from both sides, that's going to give me x equals negative 3. Alright, that's a vertical asymptote. If I set x minus 3 equal to 0, okay, I'm gonna add 3 to both sides. That'll give me x equals positive 3. That's a vertical asymptote. Okay, x equals negative 3, x equals positive 3. Make sure that you put x equals. Don't just put negative 3 and positive 3. Alright, let's go ahead and graph these asymptotes and this whole. Alright, so these are my asymptotes, and this purple open circle is my whole. Alright, show any holes in the graph as an open circle. Okay, and now let's just go ahead and look at several other values. We'll use the calculator. I'm going to want values to the left, several values in the middle, and values to the right. So for example, I'm going to look at like negative 5, negative 4, negative 3.5. I like to get real close. So let's look at those. All right. So let's start with negative 5 and go from there. So it's already in my calculator, so I'm just going to go to negative 5. All right. At negative 5, we have this, and that's 2.5. Okay, so at negative 5, we're at 2.5. At negative 4, we've got 3.4. Okay, so it's 3.4 would be like right here. Alright, I'll come back and look at the decimals afterwards. Obviously I'll have an error at negative 3 because of the asymptote, but then I'll take a look at negative 2. All right, at negative 2, I've got a negative 0.8. Okay, so that's almost down to negative 1. All right, at negative 1, I had 0. What about 0? Hold on. At negative 1, had 0. Yeah, okay. At 0, we have 0 also. Interesting. Okay, so it must be going up and then coming back down. Okay. Alright, and then at 1, we have negative 1/2. That'd be right here. And at 2, we have this. That's negative 2.4. So at 2, we're at negative 2.4, which would be about here. And again, I'll come back and do the decimals afterwards. But let's take a look at 4. Alright, because 3, there's our asymptote. At 4, we have this, which is 5.7. Okay, so here's 5.7 would be like about there. And let's take a look at 5. Okay, at 5, I have 3.75. Okay, so that's like about here. And what about 6? Okay, 6, I have 3.1. Okay, at 6, that's about like right here. Okay, I can see what's happening. I'm going to skip to 10 just for fun and see what's going on at 10. At 10, I have 2.4. Okay, so 2.4 would be right about here. Okay, now I'm going to go back and do the decimals. I always like to look at what's happening really close to the asymptotes, just to the left and just to the right. But to do that, it's easier if I do ask mode instead of auto. Okay, so for example, the asymptote is at negative 3. So I'm going to take a look at negative 3.5. Okay, so negative 3.5 gives me this. You know what, while I'm here, I'm going to do negative 3.5. I'm going to do negative 2.5. Negative 2.5. And jumping over here, I'm going to do positive 2.5. Alright, it'll only let me do 3 at a time. But let's check these out one by one. So this one at negative 3.5 is 5.4. So this right here, 5.4 would be about here. Okay, now this next one on the other side of the line is right here. I'm going to toggle it. That's negative 2.7. Alright, so negative 2.5 gives me negative 2.7, which would be about here. Okay, now this last one, which is really close to 3, so 2.5, toggle it, that's negative 6.4. Okay, so here's negative 6, negative 6.4 would be about right here. Alright, so that really gives me a good idea of what's going on. And one more. Right here next to this asymptote, I'm talking about 3.5. Let's take a look at that. Okay, that is 9.7. Okay, so at 3.5, I'm all the way up here at 9.7. Alright, I'm almost off the chart. Alright, the moral of the story is don't be stingy with your points. You've got a TI-30XS multi-view. You can get as many points as you want. And the more points you graph, the more accurate your graph is going to be. So don't hold back. Okay, now I'm just going to connect the dots and draw the graph. Alright, so your graph should look something like this. Notice the open circle. I'm definitely going to leave this as an open circle right here. Don't just draw through it, because that's a hole. That's not part of the graph. Alright, it's empty. Alright, so clearly this graph is not continuous. It is discontinuous. Now, these asymptotes are called non-removable discontinuities, okay? Because they are infinite discontinuities, and they are non-removable. So we've got those. Let's go ahead and just name them. Okay, they are all the asymptotes here. So it's the x equals -3, the x equals 3, and the y equals 2. These are my non-removable discontinuities. But we also have a removable discontinuity. It's the whole. Alright, the whole is a point discontinuity. So we have a removable discontinuity that is -1, 0. Okay, so it's definitely discontinuous. Now, as far as the domain, normally we would give our domain in 3 pieces, okay? The left, the middle, and the right. But we actually have 4 pieces because this discontinuity, the whole, separates this middle part into 2 parts. Okay, so I'm going to have to actually give the domain in 4 separate parts. Okay, so the first part is going to be from -infinity to -3. Okay, it's going up to the asymptote. Okay, so -infinity to -3. And of course I'll use a round parenthesis to show that you can't reach the asymptote. Okay, and then this part right here goes from -3 to -1, because that's where the hole is. So -3 to -1. Again, you can't include the whole, so we use a round parenthesis. Okay, and then union. And the next piece here goes from -1 to +3. -1 to 3. Union. And then the final branch here goes from 3 to infinity. Alright, x values only. 3 to infinity. So 4 parts to this domain. Okay, I think that is everything that we needed to do for problem number 5. And unfortunately, that's taken up all the time we have for this particular video. So I was hoping to get 2 problems done in one video, but that's not happening for number 5. Okay, so we'll pick up with number 6 on the next video. I'll see you on the next video.